Hello everyone and welcome back to the channel. Today I will teach you about the principles of binary search and when you know where to use it and how to use it. Okay, so the binary search is an advancement over regular linear search by improving the complexity from linear to logarithmic. If your data set is sorted or in a sorted manner, you can apply some binary search techniques to get your answer in an optimized manner. This is how a binary search loop works in real life. Okay, you have a start index and you have an end index. This is your binary search limits, and then you choose a certain mid. Okay, you choose a certain mid, and then based on the value of that mid, you choose whether you want to update your search, or sorry, you want to update your start or update your end. Usually when you have an ascending order array and the element you are finding is less than the element that you want, then you update start, which means update start means that you want to search in an higher search space. Means now you are searching between 1 and 12. If you want to update start, that means that you are searching on a higher place, like when you updated start. Now values from 1 to 5 are gone. So now you are searching directly from 6. When you know कि 5 is less than your suitable answer, then you can skip all the values less than 5 and directly go to 6. Okay? In a similar way, when you find a value higher, then you update your end, because if you know that your answer is greater than whatever you want, then you don't need to check any further greater values. So updating end brings the search down into a smaller value of search. Okay, and at the end of the search, you find a suitable answer for your given problem statement. Now, this is how we can use this technique and principles to solve a question based on binary search. Now, one very important principle while learning binary search is binary search on a monotonic function. What does this mean is, maybe from some value 0 to x, all of those answers are invalid, which means you cannot complete your answer in x amount of moves or x amount of points, something like that. And from x plus 1 to infinity, all of those moves are valid. For example, suppose you want to find the minimum number of moves for a boss fight and the answer is x plus 1, which means कि in x plus 2 moves you can also win, in x plus 3 moves you can also win. Basically from x plus 1 to infinity, in all of those moves you can win. It's just that x plus 1 is the minimum. So your valid subset is a continuous function. Okay, that's when this problem is suitable using binary search on monotonic function. It can also be reversed, like answers from 0 to x are valid and x plus 1 to infinity is invalid. This is when you maybe want to find the max out of all valid solutions. Like let's say you are making food and you can make around 10 breads, which means you can make 9 breads as well. You can make 8 as well. Any answer from 0 to 10 is valid with the ingredients that you have. It's just that 10 is your maximum possible value. Okay? So, how do you perform binary search on such questions? Let's say let's say your solution is is like this. This is true and this is false. This means from this point onwards to right, all of the answers are invalid, and from this point to the left, all of the answers are valid. It's just like the bread making question which I just explained earlier. If you can make 10 breads, 9 breads is also a suitable answer. 8 is also a suitable answer. With the same ingredients, if you can make 10 breads, you can also make 9, 8, 7, 6. How many number of breads? It's just ki 10 is the most maximum possible value. So to find, you have all subset of true, and you need to find the maximum possible value of true. So this is how you do it. You start your search page from 0 to infinity, and you will receive a mid. Whenever you receive a mid, you check whether with this value of answer, is my answer valid or invalid. If my answer is invalid, which means I cannot use all of these solutions, so I will update my end and search on this space again. If my mid comes as true, which means that this is one possible answer of mine, and then I can continue my search on the remaining space by updating your start. And at one operation or another, you will find the mid that is your maximum value. For reverse, like 0 to x point false and x plus 1 to infinity true, you need to do the same thing in reverse. If you find a true value, you update your end and search in a lower area. If you get false, you update your start and search in a higher area. Okay. Now this same principle is formally called as strictly greater number or strictly lesser. Let's say you have some solution set 1, 2, 3, 5, 6, and you know that 1, 2, 3 are valid options, 5 and 6 are invalid options, which means I need to find the maximum, which is 3, which means I needed to find the greatest key that is strictly less than my number. Let's say you are searching the strictly lesser key for 4. The answer is 3. 3. And this is the principle that we used in the previous question. From 0 to x, all were true. From x plus 1 to infinity, all were false. So I need to find the strictly lesser key which gives me true. And that is my maximum answer. And the same thing reversed. If this is invalid and 5 and 6 are valid, which means I need to find the minimum here, which is 5, which means the least key that is strictly greater to 4. That is your strictly greater key. Like if 1, 2, 3 all were false and 5, 6, 7, 8 infinity all were true, then I need to find the minimum possible value of true, which is my strictly greater key. Okay, now I'll show you a few questions on how you can use this concept. Let's see, for example, this question. You are given n chickens and each of them have an egg production rate. You need to determine the minimum amount of time to get x number of eggs. For example, if you want 7 number of eggs and your egg production rate is 3, 2 or 5. Like for every 3 seconds the first chicken gives an egg. For every 2 seconds the second chicken gives an egg. So in 8 seconds I will get 2 eggs from the first chicken, 4 eggs from the second kitchen and 1 egg from the third chicken. So I get a total of 7 eggs. Now with binary search, how can I find the minimum possible answer? Okay, now let's say I am getting my minimum answer in x seconds. That means all of my answer from x up to infinity, all of them are valid answers, because if I can get 7 eggs in 8 seconds, in 9 seconds I will also get at least 7 eggs. In 10 seconds also I will get at least 7x. But from 6, 5, 4, all of the values, I will get less value of x. So this sum is of this way. False, 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 true, 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 true. And you need to find the minimum possible true. So this is how you can use binary search on this. First of all, you keep your start at 0, keep your end at infinity. You get a certain mid. Now you need to find, is the answer valid for this mid? Let's say we got mid is equal to 10. Then I will check in 10 seconds, am I getting at least 7x? If yes, that means the answer is 10 or less than 10. So I can decrement my end and search for a lesser answer. But if I get less than 7x, which means all answers less than 7 are wrong, which means I will update my start and continue searching from 8 in hope for a suitable answer. And so this loop works at maximum of log n iterations. If your infinity is 10 raised to 18, this will work at max 64 times, and your check function might be O of n. So the complexity for these type of sums are n log n. And so the check function is a part which is kind of easy. Like if you want to check whether for this amount of answer is the answer true or false, then most likely you could get it easily instead of finding the minimum possible answer. So by binary searching on all your possible answers like this, you can find your minimum answer very optimally and easily.